Alright, so today we're going to do some trig equations. You just have to keep your unit circle in mind and think of it just like a regular algebraic expression. The key here is to isolate your variable. In this problem it's our angle. So we're going to isolate theta, and in order to do so you're just going to pull everything away. So if you think of it like 2x plus 1 equals 0, you're going to reverse PEMDAS. You'll subtract 1 and then divide by 2. So 2x is negative 1, divide by 2, that would tell me x is negative 1/2. The same thing is going to apply, we're just going to throw in a trig function. So now we're going to do the same steps. We'll subtract 1, so that leaves 2 sine of theta is negative 1, divide everything by 2, that gives me sine of theta is negative 1/2. We're looking for theta, and we do not see an inverse sign, so that tells me that it is not restricted. So if we're thinking between 0 and 2 pi, how many times sine is negative 1/2? That happens twice. So we're going to find those two angles. Well, sine is negative in the third and fourth. So if we're talking about where sine is 1/2, that's going to fall at 7 pi over 6, and it's also going to fall at 11 pi over 6. So those would be the two times between 0 and 2 pi where this equation is true. If we want to come up with the general solution, all we need to do is think about when these values repeat. And we'll talk more about this in class, but you want to get an idea of what you're doing. So if we think about sine, the original period of sine is 2 pi. That tells me that every time we go 2 pi units around, we're going to get back to the same place. That's where we repeat. So if I look at this equation, the number in front of my theta is going to affect the period. Well, since that's like a 1, we're going to find the new period by doing 2 pi over 1. Well, that's going to give me my 2 pi. So the same period is true. That means that these values are going to repeat every 2 pi units. So we're going to add 2 pi k to the end of that equation. And we have my general solution of 7 pi over 6 and 11 pi over 6 plus 2 pi k. K is any number, so that means every 2 pi units it repeats. Let's build on that one. So we're going to do another equation. This time we have cosine of x plus cosine of x plus radical 3 is 0. The problem with these is that there are so many different ways these equations can look. You just kind of have to look at them and recognize that it's just an algebraic expression. If I had 2x plus radical 3 equals 0, you could combine like terms. We could say we have a total of 4x. Same thing is true here. We're going to combine like terms. So we have a total of 2 cosine of x. We can't do anything with the radical 3. Now we could have at that step got it to the other side, but from here it is no different than the problem we just did above. So we'll subtract radical 3 and divide by 2. That's going to give me cosine of x is negative radical 3 over 2. Now I have to find the angle, so we're talking second and third quadrant. That's going to occur at the 6's, so that's going to be 5 pi over 6 and 7 pi over 6. The period of cosine, once again, is 2 pi. There's no number in front of my x or theta to affect that, so the next time those units are going to occur is 2 pi units later. Let's move down. Let's do another one. We're going to go through a total of 5 of these. So we've got 2 sine of theta minus radical 2 is 0. Just as easy. We're going to go through, we're going to get theta by itself, so we'll add radical 2. So 2 sine of theta is radical 2. Divide by 2. That gives me sine of theta is radical 2 over 2. That's going to happen at my 45's, but because we want a positive sign, that's going to happen at pi over 4, 3 pi over 4. And if we continue around, the next time we're back to that same place, if we think about it like the unit circle, here's pi over 4, here's 3 pi over 4. So those are the two angles that satisfy this equation. We cannot use third and fourth quadrant because that's going to give me a negative value. And the next time that we're going to get back to these, oops, let me fix this. The next time that we're going to get right back to the same position is 360 or 2 pi units later. That's why we're adding that period onto this equation. And the next time, if we want to go around again, would be a total of 4 pi or 2 pi times 2. Once again, we're going to talk about this in class. This is the main focus that you guys should be able to take from this video. Alright, continuing on. Let me move this up if I can. We're going to do tangent squared this time. So remember, the squared in between is the same thing as tangent of theta squared. So now what we're going to do is we're going to get rid of a square by taking a square root. That's going to leave tangent of theta. And then on the right side, you have to remember plus or minus. Square root of 1 is 1. The square root of 3 is radical 3. If we were to rationalize this, that would give me plus or minus radical 3 over 3, which from the unit circle we know it's going to be all four of them because it's plus or minus, which makes it nice. So it's coming from all four quadrants. But we're going to go through and we're going to say, okay, tangent is radical 3 over 3 at pi over 6. So it's going to be all of my pi over 6 is because of that plus or minus. So 7 pi over 6, 11 pi over 6. Now you have to be careful. You can't see that anymore. You cannot get in the habit of just saying plus 2 pi k because the period of tangent is pi. So for the general equation, we're going to take pi divided by the number in front. So this time it's just pi k. And then the last one, cosine of 2 theta is 1/2. Anytime you have a number with your theta, you're going to leave that alone until the very end. So we're going to solve it. We're going to say cosine of an angle is equal to 1/2. Well, that angle is going to be pi over 3, and it's also going to be 5 pi over 3. We did not solve for theta. We solved for the angle that gives me that. So we know 2 theta is equal to both of these values. In order to solve for theta, you would just divide by 2. So that tells me theta is pi over 6. If we divide 5 pi over 3 by 2, we get 5 pi over 6, just fraction work. Those are the first two times that that value is going to occur. If this had just been a theta, we would say plus 2 pi k. But because there is now a value in front, we're going to take 2 pi, my original period, divided by 2, and we know that the next time that these values are going to occur is 1 pi unit later. So that would be my general solution. Alright, in your notes, or on a separate sheet of paper, I'm going to give you guys 2 problems to try. I want you to try sine squared of theta is going to be 1/2. And I want you to try tangent of 2 theta equals 1. See what you can do with those, bring them into class, and I'm going to check you off.